Welcome to the Journey Shake Chem. Well, today in the warm-up we're doing complete half reactions, so please do the best you can and I'll see you in a moment. In number 1, we are looking at the permanganate polyatomic ion. And oxygen has a charge of -2, and there are 4 of them. That gives me a -8 on the oxygen. It's important to understand that the oxygen has a charge of -2 and not -8. Well, I'm looking for the manganese, and this is a polyatomic ion that's equal to -1, and therefore, in this case, manganese is +7. We have had a change from +7 to +2, and we have to think this one through. Electrons are negative, and here I am in debt 7 electrons, and now I'm only in debt 2 electrons, therefore I must have gained 5 electrons. And we call this reduction. And in order to balance an equation in an acidic solution, we can only add 3 things. We can only add hydrogen ions, water, and electrons. And not hydrogen, the diatomic molecule, because that would be a gas and it would bubble right out of the solution. So we need the hydrogen ions, and that's what makes it acidic. And therefore, when I look here, I have 4 oxygens, and I have no oxygens here. I must add 4 oxygens. So I will take 4 waters. That's the only place that I have oxygen. Plus 4H2O. As soon as I add water, then I'm going to need my hydrogen ions. And I'll need 8 hydrogen ions to balance the hydrogen ions. 8H+. Now I must also balance the number of electrons, and I gained 5 electrons, and when I gain 5 electrons I'm going to add them to the reactant side, 5 electrons, and by adding 5 electrons to this +7 it becomes +2, and I have +2 on the other side, and then that half reaction is balanced. In the second one, I must first recognize the fact that there are 2 atoms of iodine here and only 1 atom of iodine there. And I must put a coefficient of 2 in order to get 2 atoms of iodine. Now this iodine is a diatomic molecule, so it's 0. And oxygen here is -2, and there are 4 of them, which gives me a -8. And I'm going to erase the things I'm allowed to add. And the whole thing is -1 because it is a polyatomic ion. And therefore this iodine is +7. And therefore, we have gone from 0 to +7. We have lost 7 electrons. And therefore, it is oxidized. You'll recall oil rig. Oxidation is losing electrons. Reduction is gaining electrons. And I found that it's kind of interesting that in this case, we went from +7 to +2, and here we lost 7. I don't know, I'm funny like that. Anyway, we need to add those electrons back in. And we lost 7 electrons for 1 atom. And I always do these for 1 atom. And therefore, if I have 2 atoms here, I have to double the number of electrons. And therefore, I lost 14 electrons, and I'm going to add the losers to the product side. Losers are produced. Or losers are on the right. Whichever one you prefer. Then I have 4 times 2, which is 8 oxygens that are required. And therefore, I will add 8 waters. And when I add the 8 waters, then I must add 16 hydrogen ions. And then it's balanced. And it's very important to pay attention to these two atoms because that changed the number of waters that I needed to add. That's 1 and 2, and I'll be right back. In number 3, we have a compound that we should recall is hydrogen peroxide. Now, there are two ways to go at looking at the charge of the oxygen here. First of all, let's do it as a compound. Hydrogen is +1 times 2 is +2. Plus 2x equals 0. And therefore, oxygen is -1. Although I could also say that the peroxide ion is -2. And therefore, 2 atoms is equal to -2, and therefore it is also -1. In any case, oxygen has a -1 charge there, and hydrogen is +1 on both sides. So there's no change going on for hydrogen. Oxygen in water is -2, and therefore we have gone from -1 to -2, and we have gained 1 electron. Then I must pay attention to the number of atoms. There are 2 atoms of hydrogen here and only 1 on the product side, and therefore I'll put a 2 coefficient. Now, students have asked if I could just write +1 more water, and that would also be fine. However, I prefer to use the coefficient because that's consistent with normally how I do it when I see that there are 2 atoms, as we will see in the next one as well. Now, I have gained not just 1 electron because that's for 1 atom. I have 2 atoms, and I gained a total of 2 electrons. And I have 2 hydrogens here and 4 on the other side, and therefore I need 2 more hydrogens to balance this equation. And then it's balanced. This half, remember, they're only either an oxidized half or a reduced half, and tomorrow we're going to learn how to put them together. But for now, we need to slowly go at this so that we understand half reactions completely. And here we have oxygen. This is a compound. Oxygen is -2. There are 4 of them, giving me a -8 on the oxygen. There are 2 nitrogens, and this is a compound, therefore it is 0. In this case, nitrogen comes out to be +4. Oxygen on this side is -2. There are 3 of them, giving me a -6. It is a polyatomic ion with a -1 charge, and therefore, in this case, nitrogen comes out to be +5. And then I also must notice that I have 2 atoms of nitrogen, so I'm going to put a 2 coefficient in the front. And you'll notice that the oxygen has not changed its charge, and therefore it is not involved in the redox. And I went from +4 to +5, which means I lost 1 electron. It is oxidized. I'm going to add these 2 electrons back in to get the charges to be the same. And then I have 4 hydrogens on this side and 4 oxygens on this side. And I have 4, I'm just having a hard time, but I'm sure you understand you have hard times too sometimes. And anyway, here we are looking at the oxygens. So looking at this oxygen, I have 4. I can read the numbers. And here I have 6 oxygens, and therefore I must add 2 waters. I'm going to erase this number. It's in my way. So now I have 2 waters here, and therefore I must add 4 hydrogens to the other side. And then it's balanced. We just take on those challenges. I know you can do these half reactions. Just have to pay close attention to when there's 2 atoms. Now, I wanted to talk to you about one more thing about number 3. So I'm going to go ahead and erase number 4 in the warm-up. And warm-ups are always good places to learn new things. We know that when we have hydrogen peroxide and we injure ourselves and we have a wound, we pour hydrogen peroxide on that wound so that we clean it up and get those bacteria out of there. And when we do that, we see bubbles. Well, what are those bubbles? Those bubbles are oxygen. And therefore, we get oxygen. And oxygen as a diatomic molecule has a charge of 0. And therefore, here, oxygen is also losing one electron. It lost one electron for each individual atom. And therefore, when we have hydrogen peroxide and we use it, it is an oxidation reduction type of reaction because there is something that is gaining electrons and losing electrons, and both are required for a redox reaction. And I thought that you would remember that. I'm sure everybody's used hydrogen peroxide before, and you know how it comes in a brown bottle because it's very sensitive to the light. So we keep it in a dark bottle so that it doesn't react with the light and decompose into water and oxygen. And that would not be very effective hydrogen peroxide if it was two different compounds. Well, you see, it happens all around, and we're happy that we know these things so that we can get better when we're not well. Well, that's all I have for you today. I'm sure your facilitator will go over the assignment with you, and then you have some more half reactions to practice for tomorrow, and then we're going to learn those new complete redox reactions in acidic solution. Well, thanks for being here, and I can't wait to see you tomorrow. Bye.